is incumbent upon every visionary and every practitioner of technology to ensure that future generations have a home. Humans are not the problem. Hubris is, greed is, complacency is. Now is the time to leverage what we know for the benefit of posterity.
Welcome to the Friends of Space Resources podcast, a place to explore space resource exploration and utilization. What is it? Why it matters? And why it's so vital to the future of space investigation. Each week here, we'll meet with a technical expert in the field of space resources to better understand and gain deeper insight into their field of study. Welcome your host, Valerie Eastman.
Welcome to Friends of Space Resources. I'm your host, Caleb Eastman. Every week we host either a guest who specializes in space resources or a relevant field. It's really important to understand the perspectives of experts all across the different fields. One of the specific fields that is really important is the field of robotics. It's pretty well agreed that robotics is going to be an important, actually the critical factor for surviving in space. However, there's a lot more to robotics than just it working. It must also be able to interact with humans. So today we have an expert in human-robot interactions, Dan Grollman. I'll just let you introduce yourself, Dan.
Howdy. Thanks for having me, Caleb. Yeah, I'm Dan Grollman. I run the Boulder office for Plus One Robotics. I've been doing human-robot interaction, particularly machine learning, applied to human-robot interaction for a bit over a decade now. It's what I love.
That's awesome. So why don't I just go ahead and have you introduce the concept of human-robot interactions for people who may not be as familiar with the concept and what it means and what it entails.
Sure. So human-robot interaction throughout the field of human-computer interaction. How do people interact with technologies? It's great that things just do the thing you want to do, but somehow you need to interact with a human either in their space, or you need to get instructions from a human, or you need to get feedback back to a human. For computers, this is things we're all familiar with: keyboard, mice, monitors, etc. Robots add a whole nother dimension to it because robots are embodied. And so human-robot interaction looks at everything from how do you physically interact with a robot when you can touch it and move it? How do you verbally interact with it? A lot of people do speech commands to a robot. Everything to an area that I'm particularly interested in: how do you exist side by side with the robot when you're both doing your own things? All this falls under the auspices of human-robot interaction.
And as I understand it, part of your expertise is in machine learning as it relates to the use of machine learning as it relates to improve human-robot interactions, particularly from the robotic side. How does that skill set apply? I'll say aid you in the HRI.
Yeah, so humans are non-static. They adapt, they change over time. And so when you have a robot existing alongside a human in any sort of way, you expect some adaptation on the robot side as well. And that's where machine learning can really come into play. When you have humans there giving you feedback on how the robot is behaving, you want to adjust the robot's behavior as quickly as possible to either conform to human expectations, to make the human more comfortable with the interaction, or just to improve performance.
I got the jet engine just going. Yeah, the reason I don't only use this computer is because of that. But I'll just stay muted while you're talking because the video's on you and the audio's on you, and I can. So speaking of human-robot interactions, when we talk about classification in a machine learning sense, it's important to understand the context for what the classifiers are doing. So one example is context classification, which is in the field of wildland firefighting, for example. In most places, when someone's completely bent over, they're usually hurt, and a classifier might say that. But in the field of firefighting, there's a posture that they train you in that looks bent over, but it's really just putting your elbow on your knee so you can dig a trench for 8 hours a day. And so in that case, it's not. Talk to me about your approach to context classification, particularly in specialized fields where maybe a motion or a pose doesn't mean the same thing it does in other fields.
Yeah, you touched on a few things there. One is the separation between the movement and the meaning. And if you're training a model to recognize the movement, well, that's great, because then you can swap out the meaning behind the scenes. You can have a firefighting meeting that you load on, you use the same classifier to detect bent over versus helping people possibly in pain meaning that would use the same classifier but would change what it means. How you switch those contexts, that's, I think, where some of the interesting stuff that you've been questioning about lies. One way to do it is just do it by hand. You say, hey, robot, load up firefighting mode, and comes with all a bunch of classifiers and a bunch of the meanings behind the gestures. But then you need to explicitly say, robot, switch out of firefighting mode and go into hospital mode. Another way, and this is the techniques I look at, is estimating that hidden state. There's some sort of hidden state that tells you which model you should be using, and you need to be able to predict that. If a robot is in an environment and there's lots of people wearing firefighting uniforms, maybe the firefighting mode is appropriate. And if you're in a scenario where lots of humans are wearing doctor's scrubs and there's an ambulance, then maybe hospital mode is appropriate. So it's understanding what these latent modes are and being able to intelligently switch between them. That is, I think, a very fruitful area of work.
And that latent node concept seems pretty powerful, because that allows you to even differentiate between a firefighter is bending over and their helmet's on, then maybe, and they've shoveled their hand, maybe they're digging, but if their helmet's off, it's possible that they're hurt.
Yeah. So there's this idea of latent spaces or hidden variables, I think is really powerful, because humans do this all the time. You act differently here in this interview environment than you would perhaps at home, or perhaps at work, or perhaps at a party. You switch context all the time. And if I were to ask you right now to write down every possible context a robot might find itself in, that's a really hard task. And so being able to estimate how many different contexts there are from lived experience, or lived but experienced experience for the robot, I think that could lead to some really interesting models.
So in that sort of what I'll call it context, a lot of the way that they train models in autonomous vehicles is a lot basically throwing armies and armies of people at the annotation process. You've written about this before, and so I want to touch on it. So in the annotation process, it's a bunch of people who can identify a stop sign, but in these, I'll call it subject matter expertise laden areas, highly contextual, lots of latent variables, your average human wouldn't be able to annotate in a lot of the same ways that we would in more approachable domains. So in the unapproachable domain space, how do you scale annotation? And
yeah, excellent. I've written about this before. I'm opinionated on it. Feel free to take anything I say with a grain of salt. I think our dependence on data is unsustainable, particularly on annotated supervised data. Our models that we're using a lot of these days, just going to broadly say deep neural nets and things like that, are wonderfully flexible, but require massive amounts of data to focus in on what it is they need to learn. There's alternate approaches where you put more information into the model, let the model know more about the domain in which you're expecting to operate, which could be more efficient with how much data you have. There's also all sorts of fun techniques. There's data augmentation, there's sim to real, or you simulate data and then you get your labeling for free, and then you just use that for training a model to reduce this need for human annotation. But I think we have to go back to our models and figure out how to make them more efficient with less data. And particularly in some of these highly specialized domains, I think the only option is going to be gathering your data in situ. You have to put the robot or the system in the environment and collect that data and be very parsimonious with how many times you ask humans to label it for you, because they might be very busy or very expensive. And we need to focus some research on techniques that can do that.
Along those lines, we talk about talk about models and we think about the algorithm itself, but there's also the concept of the data model itself. Is there a data model or a sort of a system or a framework that you have found that is highly successful in dealing with where the metadata needs to come from other places other than just straight up annotation, or you think that's still something that needs to be built?
I don't know if I have a really good answer for that yet. I think it's a thing we are figuring out. The field of HRI is not really that old. And the field of machine learning from human data for robots is even younger. We're still figuring a lot of stuff out. The approaches we have now have worked really well, but I think we really need to be open to the possibility that they will not continue to work in the future.
That's really interesting. It seems like a lot of machine learning, when we talk about it, it seems like it's generally used for I'll call it the perception. So the ability to identify or classify things. I'll call it generally underappreciated is the difference between perception and reasoning for robotics. And I'm curious how you see the evolution of machine learning for perception or its applicability for deliberate thought, deliberate tying causal links between things, or the reasoning, how you see that. It's called explainable AI, but
explainable AI is a wonderful effort, particularly as AIs and machine learning models get more and more complicated. Being able to tell a human why it's doing something, it certainly helps a lot, particularly for human robot trust. If a system explains itself to you, you might trust it more. On ML beyond perception, there certainly are approaches that do full loop. You direct perception to action. My dissertation work looked in that field where we learned a direct mapping from what do you see to what should you be doing in response to seeing that. I think there's still some interesting work to be done in there. For most use cases currently, the things to do are pretty well understood. It's just how to figure out what you're seeing. That is the hard part, and that's where most effort has been focused. In terms of higher level reasoning, there's a whole nother branch of AI just around logic and planning and that sort of stuff. I think these days when people say AI, they tend to mean specifically machine learning, but there's other subfields that are very focused on how do you reason about your plans, and given the target state of the world, how do you get there? There's lots of fruitful work there that could be brought to play.
So we'll circle around to a pet peeve of mine as it relates to HRI. It seems robots that operate more in either the consumer space or what I'll call maybe the in office or the cubicle office space, such as Cosmo or Misty, these small robots that lack we call payload capacity, tend to be very good at HRI. But industrial robots, I'm looking at you, Boston Dynamics, and other, I don't want to call out KUKA or anybody, but just basically the high capacity, high payload robotics tend to not focus so much on HRI. So there seems to be still a weakness, particularly with industrial robots.
Absolutely.
So you just answered the question. The first question is do you agree that that's a problem? And B, why do you think that is? And what do you think we should be doing about that?
So I do agree. Most industrial robots are not designed to be human friendly. This sort of comes out of the histories. They move very fast. They can carry great payloads. They can cause massive amounts of damage to a human. So you tend to put them in cages away from humans. And so HRI and proximate HRI isn't really a concern because there's no humans nearby. Consumer robots, on the other hand, I'm going to say Furby, if we can call Furby a robot, their goal is to be adorable and to get people to buy them. And so there's a much more of a focus on that sort of what's it like to touch, what's it like to hold, what's it like to interact with. And so it just comes out of the history of both of those domains. What I see now, and what I'm starting to see now, what I'm really encouraging is these things need to cross over. So as with the advent of, say, Cobots, Universal Robotics makes a human-friendly arm that you can mount and you can work right next to because it's not going to hurt you. Now, concerns of human-robot interaction come into play. How does this arm, which is right next to you, express itself so that you know what it's going to do, that it doesn't surprise you, it doesn't scare you? Conversely, consumer robots are getting more and more functionally capable. So now that you've got a robot that's in your house that can actually do more things and potentially cause you damage, how do you balance the HRI with the functional requirements? My sort of pet peeve, to answer yours, is very often companies in particular, are focused on the functional requirement of the robot. Does it do the thing it has to do? And do people interact with it as an afterthought? As industry and consumer robotics start to get closer together, I think there's a big need to consider both of these things equal partners. Because if it does it and no one wants to use it, what's the point?
And that's one interesting thing is even cobots like Yumi or you mentioned the universal robots arm, it's characterized by effectively force torque sensors that can sense if it's putting a lot of pressure or whatever. But it's still, in my mind, pretty limited in terms of the idea. So it's safe to sit sort of by the human. But whenever I see sort of cobotic cells, if you will, it's generally like they're sitting across from each other and the robot does something and then the human might do something afterwards. So they're still not interacting per se, and there's still not, I'll call it there's still not like a way for human to know what's Yumi thinking or what's Yumi focused on, as an example.
Exactly.
And so I'm just, and in particular where it becomes, I think, even more significant is when as we start to see more mobile robots. So as we start to see Boston Dynamics, I've started to see Spot kind of permeating areas. I'm starting to see a lot more AMRs and a lot more scenarios. And it might be one of the higher growth areas. So I'm just curious, how you see the importance, how you see this playing out for mobile robots in particular.
I think you've really hit it on the head there. So there's some really interesting work I've been following in basically human-aware path planning for mobile robots. So as a robot is driving around, the traditional get from point A to point B as quickly as possible, we can solve that. There's algorithms that solve that really well, and there's global and local planners that will react to changes. But the key insight is that humans aren't just obstacles that need to be avoided. They're co-travelers with you on this journey through space. And so now there's models that start to come into play that model social avoidance behaviors of humans, that try to recognize the intent of where's that human going so we can mutually plan. It's the situation you come down a hall and then do you do the dance or do you smoothly move past each other? All this work, I think, needs to come into play. It's hard, though, from an industrial setting to validate its use. Because you say, hey, we're going to make the robot slower, but people are going to like it better, or people are going to get less annoyed at it. It's a hard business decision to make because we can quantify how much money we lose by making the robot slower. And it's hard to quantify how much money do we gain by making people less scared of the robot. And until we have good metrics or good ways of quantifying the gains that HRI gives, I think it's a really hard business decision to make.
So it's really funny you bring that up because in retrospect, I don't know that I've ever seen a local cost map that actually takes into account human intent so much as just it's an obstacle to be avoided, right?
There's work that does that. I'd encourage you to go look at some of it's really interesting. I did some work way back when, which looked at the jerk of humans' movement to try to predict if the human is surprised by the robot. And then you can adjust robot plans to match. There's also some really interesting work I looked at. This wasn't my work, someone else's, which mounted a projector in front of a robot and projected the path of the robot so people could see where's this robot going, what is it doing, and that led to people avoiding more effectively.
That's really interesting. So I know that we have to wrap it up soon. Just along those lines, so one robot company that was compelling to me was Baxter. If you remember
Rethink Robotics.
Yeah, Rethink Robotics, Baxter. So one thing I really appreciate about it is that like Baxter actually had eyes, and it would actually look where Baxter was focused. And so it seems to me like, particularly with mobile robots, that you might start to bring back this concept of nonverbal cues that we've almost evolved with, if you will, so that replacing the projector, if you will, by it seems fairly simple to replace the projector as for example, with eyes that are looking the direction the robot's going, if that makes sense.
Absolutely. No, there's a whole body of work on this for everything from ground vehicles to drones. How do you modify a robot to provide better indication of what it's doing? And this can be eyes, this can be colors, this can be lights, this can be expressive movements. There's a lot of work in all these areas that tell us or hint at ways that this could be done. But as far as I know, none of them have really been deployed at a large scale yet. And I think it does come back to that business decision of, we think this will help, but we don't know how much it will help. And so does that validate the added expense of more actuators or a bigger screen or additional technology that they now have to build into a robot to be able to do this? That's unknown.
So this is a phenomenal conversation. I know we have to wrap it up. If possible, I'd like to bring you back at some point, because I just barely scratched the surface, and I haven't even gotten to talking about it.
Thank you for listening to the Friends of Space Resources podcast, and welcome. Connect with us on social media by searching the Friends of Space Resources podcast, and join us online at friendsofisru.com. Check back weekly for new episodes and new insights into space resources. Until next time, look up and keep dreaming.